In this video, we are going to find the eigenvalues and eigenvectors of the given matrix A. The given matrix A is 6, minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. Let's see how to find the eigenvalues. For this, we need to find the characteristic equation. What is the characteristic equation of a 3 by 3 matrix? Lambda cube minus a1 lambda square plus a2 lambda minus a3 is equal to 0. Where lambda is the variable, a1, a2, a3 are constant coefficients. Here are the formulas to find these a1, a2, a3. We start with a1. a1 is equal to sum of the leading diagonal elements. Here, look at the given matrix A. What are the elements in the leading diagonal matrix? 6, 3, 3. A1 value is equal to 12. Now, we find the value of A2. A2 is equal to sum of the minus of the leading diagonal elements. The first leading diagonal element is 6. It's in the position first row and first column. We leave the first row and first column. Determinant of the remaining elements 3, minus 1, minus 1, 3 is the minor of this 6. Similarly, we find the minor of the remaining leading diagonal elements 3 and 3. Now, we cross multiply these 3 minors and eliminate. Now we get the value of A2 is equal to 36. Now we find A3. A3 is nothing but the determinant of the given matrix A. For this, we consider the first row elements. First row elements is multiplied with its cofactors. 6 into its cofactor minus 2 into its cofactor plus 2 into its cofactor. A3 value is equal to 32. Now we get the values of A1 is equal to 12, A2 is equal to 36, A3 is equal to 32. We replace these values in the characteristic equation. So the above equation becomes lambda cube minus 12 lambda square plus 36 lambda minus 32 is equal to 0. Now, we are going to solve this characteristic equation because eigenvalues are the roots of the characteristic equation. Now, we start with trial and error method to find the first root. Let's try some number in the place of lambda in the characteristic equation to find the value which satisfies the equation. First, we replace lambda is equal to 1 in this characteristic equation. Wherever you find lambda, you make that as 1. So, our characteristic equation value is not equal to 0 here. So, lambda is equal to 1 is not a root. We replace lambda is equal to minus 1, we get not equal to 0. Substitute lambda is equal to 2, the characteristic equation becomes 0. Therefore, lambda is equal to 2 is a root of the given equation. We start with this 2. We take the coefficients from the characteristic equation. 1, minus 12, 36, minus 32. We start with 0, we add 1 and 0, we get 1. You multiply that with the 2 outside, write that below 12, minus 12. Now this cubic equation reduced to a quadratic equation, lambda square minus 10 lambda plus 16 is equal to 0. To solve this quadratic equation, we are using the formula x is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. When comparing the coefficients, we get a value is equal to 1, b value is equal to minus 10, c is equal to 16. We substitute these equations in the formula and solve. So we get lambda is equal to 2 and 8. The eigenvalues are 2, 2, 8. Now we are going to find the eigenvectors. To find the eigenvectors, we are having the equation a minus lambda I into x is equal to 0. We are replacing the given matrix A minus lambda into the identity matrix 1 0 0 0 1 0 0 0 1 and the matrix x equal to 0. Now we multiply and reduce this one. When we multiply the first row with the x1, x2, x3, we get the first equation. Similarly, second row with the column, we get the second equation. Third row with the column, we get the third equation. Now we are going to replace lambda is equal to 2 in this equation to find the eigenvectors of lambda is equal to 2. Now we replace lambda as 2 in these three equations, we get all three equations are one and the same. So that you take any one equation Now you take x2 on one side, we get x2 is equal to 2x1 plus x3. Now you put x1 is equal to k1 and x3 is equal to k2. We get x2 is equal to 2k1 plus k2. Now we are substituting x1 is equal to k1, x2 is equal to 2k1 plus k2, x3 is equal to k2. So that the eigenvector becomes x1 is equal to k1, 2k1 plus k2, k2. Now as we get lambda is equal to 2 twice, we are going to replace two set of k1 and k2 values. First we substitute k1 is equal to 1 and k2 is equal to 0. So that our x1 becomes 1, 2, 0. And to find the eigenvector for the second eigenvalue lambda is equal to 2, we substitute k1 is equal to 0, k2 is equal to 1, we get x2 as 0, 1, 1. We get two eigenvectors for the value lambda is equal to 2. Now we are going to find the eigenvector for the third eigenvalue lambda is equal to 8. For this, you substitute lambda is equal to 8 in the first set of three equations. Now we get three different equations. So you take any two equations. I consider the first set of two equations. Here we are using cross rule method. So you write x1 divided by coefficient of x2 and coefficients of x3. Similarly, for x2, you consider the coefficients of x1 and x3. For x3, you consider the coefficients of x1 and x2. Now, you cross multiply the coefficients, you get x1 divided by 6, which is equal to x2 divided by minus 3, which is equal to x3 divided by 3. We are equating this to k. Now we get x1 is equal to 6k, x2 is equal to minus 3k, x3 is equal to 3k. Now 3 is common. Since 3 is common in all three equations, we take k as 1 by 3. When replacing k value in x1, x2, x3, we get x1 as 2, x2 as minus 1, x3 as 1. So that our eigenvector becomes x3 is equal to 2 minus 1, 1. Now we get all three eigenvectors.
Let us summarize. We first find the characteristic equation by using the formula lambda cube minus a1 lambda square plus a2 lambda minus a3 is equal to 0. Here we get lambda cube minus 12 lambda square plus 36 lambda minus 32 is equal to 0. We find the roots of the characteristic equation, which are the eigenvalues. Here we have the eigenvalues as lambda is equal to 2, 2, 8. We define the eigenvector as capital X is equal to a column matrix x1, x2, x3. We find the eigenvector using the equation a minus lambda I into x is equal to 0. For the first eigenvalue lambda is equal to 2, we get the eigenvector x1 is equal to 1, 2, 0. For the second eigenvalue lambda is equal to 2, we get the eigenvector x2 is equal to 0, 1, 1. For the third eigenvalue lambda is equal to 8, we get the eigenvector x3 is equal to 2 minus 1, 1.